Section 1.4, adding and subtracting fractions, decimals, and percents. We'll be going in order, so this section will cover fractions. It says add or subtract fractions with like or unlike denominators. We have two instances, one with like and one with unlike. Let's label them already. So we have like denominator here, and we have an unlike denominator. Let's take a look at our instructions. It says number 1, make sure the denominators, which are the bottom numbers, are the same. So if you notice in our like denominator, they're the same. So when we move on to step 2, it says add or subtract the numerators, which are the top numbers. So in this part, I see that it went from 2 numbers. So we see it went from 2 fractions down to 1 fraction. This is very important. The denominators do not get added. It is not 9 plus 9. They stay the same. So we are looking at the numerators this time. It says add or subtract the numerators, the top numbers, and put the answer over the denominator. So we see the step here. I have so many arrows. Let's get rid of those. And we see our 1 plus 2 is 3, and the denominator stays the same. We do have to simplify. Number 3, it says simplify the fraction if needed by canceling common factors in the numerators and denominators. So how do we start the process of simplification? One of the first things that I can notice, and hopefully you do too, is that the 3 and the 9, this 3, this 9, have a factor in common, a number in common. And the number in common is 3. So I look for a multiplication of 2 numbers that gives me 3. So for example, I know that 1 times 3 is 3. And I know that 3 times 3 is 9. So once I know those 2 things, then I'm able to go through here and cancel or divide out the 2 numbers that they have in common, and we're left with 1/3. What about for unlike denominators? So we still go through the same instructions, 1, 2, 3. So we make sure that our denominators, the bottom numbers, are the same. And so we take a look and you're thinking, well, they're not the same. I have a 3 and a 4. So what do? I am going to call this method 1. There's several methods to finding a common denominator, which is what we're about to do. But in this case, I'm going to give you 2 methods in this video. So this is the first method. They're unlike, so we're going to rewrite each fraction using a common denominator. So how do you find it? I give you 2 methods in this video. The first one, the one I have typed out here for you, it says we're going to take each of these numbers and we're going to multiply to the other. Okay, so I'm going to do this 4. So this numerator gets a 4 and this denominator gets a 4. And when I say gets, it means we're going to multiply. So you see it here. 2 times 4 for the numerator, 3 times 4 for the denominator. Then we do that again for the other numbers. So I have this 3, this 1 gets multiplied by 3, and this 4 gets multiplied by 3. So here it is. So now if you notice, and we call this a common denominator because they're the same. You see here I have a 3 times a 4, and on this fraction I have a 4 times the 3. They're the same. And how do we do that? We did that with a little bit of multiplication from one fraction to the other and the other fraction to the other. So now that we have the same number, you see 3 times 4 is 12 and the other 4 times 3 is 12. Now that we have the same number, we can move on to step number 2. Add or subtract the numerators, which is the top numbers, and put that answer over the denominator. So we have simplified like we did before to one denominator number, just one 12 instead of two fractions. We're down to one fraction, and we have our numerators, which was 8 minus 3. 8 minus 3 gives us 5, and 5 over 12. Remember, the denominator does not change. We worked really hard to get to the 12, so it just stays that way. Let's look to simplify if needed. So we want to ask if we can simplify anything. I start comparing the 5 and the 12 to see if they have anything in common. Do they have a 2 in common? They do not. What about a 3? Do they have a 3 in common? Can I do like 3 times something is 5? Because I know 3 times 4 is 12. But I cannot do 3 times something is 5. So they do not have a 3 in common. What about a 4? Yes for the denominator, for the bottom, but no for the top. What about a 5? Yes for the top, but no for the bottom. Therefore, I went through all of my possible numbers, all the way from 1 to 5, and they had nothing in common. What about bigger? Maybe you're thinking, well, what about 6, 7, 8? Well, 6 would not have something in common with 5, therefore I can't go past that. We will practice simplifying some more. So let's go ahead and try some examples. The ones that are highlighted, we're going to try. Let's take a look at example A. The first thing I do is look at the denominator. I look at my denominators. Are they common or not common? So in our case, they are common already. I'm ready to write these over one fraction. So we're going to have this. It's going to be 1 plus 2 plus 3. And we're ready to add. 1 plus 2 is 3. 3 plus 3 is 6. 6 over 7. Can I simplify? Well, let's go through our list really quick. I will give you some tips and tricks on most common simplification. You will hear me mention these all the time. 2, 3, and 5. Okay, so my first thing is I check if both numbers are divisible by 2. And that means they both have to be even. So I'm looking here and I'm looking here. Are they both even? No. So 2 is out of the question. What about 3? Do they both have a number that is multipliable by 3 to get to 6? So for example, 3 times 2, ooh, that gives us 6. But is there a 3 times something that gives us 7? No. So 3 does not work. We can't use that. How about 5? Neither one, right? 5 times something is equal to 6? No. How about 5 times something is equal to 7? No. These are my most common numbers, and it helps me determine if anything else works. Now, I'm not saying these are the only things you should check, because there is a lot more things to check, but this is what kind of gets me started, gets me in the groove. So this tells me that 6 over 7 is as simplified as it can be. Example B goes into unlike denominators, right? So I take a look and I'm noticing that 4, 6, and 3 are not the same denominators. So in this case, I'm going to show you a second method. I love knowing different methods because it gives me freedom to do something however I want. Sometimes when you only know one way, it's not the easiest or simplest way to do it. So I'm going to show you a second method, and this is meant to help give you the freedom of choosing what you like to do. I'm going to call this finding a common multiple. And really, the other method does the same thing. It's just done differently. We're going to take each of these numbers and I'm going to multiply them by something until I get to a similar number. So I'm going to start with 1. I'm going to do 4 times 1. This is 4 times 1 is 6 times 1 is 3. So what we're going to look for, the common number is going to be here. Okay, so are these the same? No. So that didn't work for me. Let's try again. So let's go 2. So I'm looking here. Now you have options. These two right here are similar, but I don't have a 6 for the 4 over here. So 6 is not working for me for 4, but it works for the 6 and the 3. Let's try again. Ooh, okay, so what am I noticing? I see a 12 here, I see a 12, but no 12 over here. But guess what? I can already tell, and I'm not going to go further on the 4 and the 6, but I can tell that if I do one more step, I can get to a 12. Okay, so notice over here when I went over method 1, you multiplied each number by something, and then you got to a common number. That's the same thing we're doing here. We multiplied by something, and then we got to the common number. And this is a little bit more visual way of doing things other than choosing over here just to multiply by it. But could you do method 1 on this one? Absolutely. Let's continue with method 2. So our common denominator is 12. We're going to do an equivalent step here. I am rewriting each of these in the new denominator. And you see that step here? This is called our equivalent fraction step. This must happen because you changed the denominator, now you must change the numerator. Remember, if you change one thing, you have to change the other. Okay, so what are we going to multiply by? In the numerator, we're going to multiply times 3. This would be 1 times 3. And if you're asking yourself how I did that, you have it written down, but let me show you. To get from 4 to 12, you multiply by 3. You see, it's right here. So you must multiply times 3 on the numerator. How about for the 6? To get to 12, you multiply by 2. So you must multiply by 2. And how about the 3? To get to 12, you multiply by 4. So you must multiply by 4. So this is going to be 1 times 3. For 3 over 6, it's going to be 3 times 2. And for 1 over 3, it's going to be 1 times 4. We have 3 over 12 plus 6 over 12 plus 4 over 12. I am ready, now that I have all of these are the same, I am ready to rewrite this as one fraction. It's going to be 3 plus 6 plus 4 over 12. Let's add that. 3 plus 6 is 9. 9 plus 4 is 13. 13 over 12. We always simplify all the time. Every single time you see a fraction, you want to simplify. So I'm going to write down my 2, 3, 5, see if they have anything in common. Are they both even? No. Do they have a multiple of 3? Can I write 3 times something and it's equal to 13? No. How about 5? Can I write 5 times something and it's equal to 13? No. So since I can't do my first common ones, then now I check each one. So for example, can 12 be divided into 13? No. This answer tends to make students uncomfortable because it is what's called a improper fraction. We leave it like this. If I don't have to do extra work, don't do extra work. We will not, do not turn it into mixed fraction. This is a common problem because students, I think it's just uncomfortable. Students are uncomfortable with this and they want to make it into something like 1 over 1 over 12. We don't need to do that. Although it is true and it is equivalent, you do not need to take that step. All we need to do is simplify, but does not mean you should go into a mixed fraction. Let's take a look at example C. C is neat. It's different from the other two because one is a fraction and one is a whole number. So this guy's a whole number and this one's a fraction. So we need to fix that right away, and we need to make both of these into a fraction. And what we do is we put the whole number over 1 all the time. So we place over 1 to make it into a fraction. Now we just do the same steps that we did, which is the common denominator. Because I'm asked to add or subtract, my first step is to look at the denominators. This happens to be unlike. We can label it as unlike or not common. Therefore, we need to go into our steps of finding a common denominator. You are welcome to use method 1 or method 2. In this case, I'm going to go back to method 1 because it's really easy. What does method 1 tell me? To take the 5 and multiply the top and the bottom here, the numerator and the denominator. And then I take my 1 from this fraction and I multiply it on the numerator and I multiply on the denominator. Equivalent fraction step here. So I have 5 over 5 minus 2 over 5. Remember, this is necessary, your equivalent fraction step. Now I'm able to write them as one fraction. The denominator stays the same. You do not change it. You do not, definitely do not say 5 minus 5 is 0 because that would make your fraction undefined. So we are ready to subtract. 5 minus 2 is 3. 3 over 5. Let's simplify. I like to use 2, 3, 5. To check 2, are they both even? No. To check 3, can they both be divisible by 3? No. The numerator can, but the denominator can't. How about 5? Both of these, the denominator can, but the numerator cannot, so this doesn't work either. Therefore, my 3 over 5 is as simplified as can be. You have 3 fractions to try on your own. Make sure to check for your denominator first thing. Are they like or are they unlike?